Hello and welcome. I welcome you to this new video. This is video number 409. In this video, I am going to test various assumptions of multiple linear regression model using STATA. And these various assumptions include the assumption of homozydicity, the assumption of no multicollinearity, the assumption of no omitted variable, and also the prediction of residuals, and checking the normality of residual, and so on. So be with me. I'm going to show all these various things in STATA. I have already opened my data file, and before doing this, let me also tell you that I'm using this model. This is the model that I'm going to estimate, and then I'll test various assumptions of this model. In this model, I'm going to use two independent variable, age and weight, which are continuous or scale or numeric variables, and two are categorical, that is health state and sex, that is male or female. So there are four independent variables in this model. Two are continuous and two are categorical or indicator variables. My dependent variable is still systolic blood pressure, and health categories are again 5, and the sample size is 10,351. So this is the model that I'll be using in this model. So here is my data file. I'll show you how to do this. So sorry, this is my data file. So first of all, as I mentioned, I will regress systolic blood pressure on age, weight, which are two continuous independent variable. Then health state is my categorical variable, which is a in this I write I dot in front of health state, and then I'm using another categorical variable, that is sex. So I will also use I dot in front of this categorical variable, which has two categories this time, male and female. And health status has 5 categories. Hitting enter is going to regress this for me. So as usual, here is my, now look at this, reg BPC stall, which is dependent variable, age is independent variable, which is numeric, weight is also independent variable and is continuous or numeric, health state is a categorical variable as indicated by I dot, and this is also, sex is also indicator, and we indicate that by I dot. So this is the analysis of variance for this model: model sum of square, residual sum of square, total sum of square. This is F state, its p value regression square r squared is 31%. So 31% of the variation in the systolic blood pressure is explained by these four variables. Adjusted r square, these are the coefficients for the two continuous variables, and both of them are significant. Then we have 4 categories for health, and for health, excellent health state has been taken as a base category, and out of these 4 categories, 3 are statistically significant, they are different from 0. And finally, this is a sex variable for which female is equal to 1, and but this variable is not significant. Male has taken been as the base category, and the last one is the constant of the model, it is significant. Now first of all, if I want to test various assumptions of this model, I will first predict the residual for this model. So I will write predict EI comma resid, that is I am telling the STATA to predict residual for me. Now you see This is the last variable in this file. Now I am predicting residual, so this variable will be generated and I will be added here. So look at this. Yes, it has been generated, and as I told you, there are 16 missing values. That is why these observations are 10,335, although the total number of observations in this file is 10,351. So the residual will have been added. Yes, it has been generated here and it has shown here. First of all, I would like to test for homoscedasticity. So for this I write a state, HETTEST. That is a state. I am telling the STATA to conduct a test for heteroscedasticity. Now here is the test results. The null hypothesis is that the variance of the residual is constant, but its chi-square p-value reject this null hypothesis, and it shows that there is heteroscedasticity in this data. After this, I can also test for IM test. So a state IM test, and this is IM test, that is Cameron and Trivedi's decomposition of IM test, and this heteroscedasticity test also shows the p-value is insignificant, skewness and kurtosis is also significant, so there is heteroscedasticity issue in this model. After this, I am using to test another assumption, that is there are no omitted variable in this model. So E-state OV test. OV test is short for omitted variable test, and again the null hypothesis is that the model has no omitted variables, but its p-value says to reject, we will reject this null hypothesis, and we conclude that there are some important variables that should have been included in this model, but they are omitted from this model. I can also check multicollinearity in that model, in this model. So state VIF, and VIF is the abbreviation for variance inflation factor. So if I press this, here is my results. Here are my results. So for age, the VIF is 1.16, and the this is the tolerance value, and if we divide 1 by this value, we get this. So these are the tolerance values and these are the VIF values, and the mean VIF is 1.37. On the whole, this test result shows that there is no issue of multicollinearity among the independent variable of this model. For this tolerance, these values should not be less than 0.2. So all of these are greater than 0.2. So there is no issue of multicollinearity. Similarly, the VIF should be greater than 5 or 10. So all these values are less than that. So there is no problem of multicollinearity. I can also estimate the variance, the covariance matrix of coefficients. So E-state VCE variance covariance, and this matrix gives us the variance, the coefficients of regression model for the covariance matrix. Now these values in the principal diagonal, these are the variances. For example, age and age, so that will be variance of age, variance of weight, variance of health state. To second category, variance of health state of 3 category, and 4th category, and all these other values other than the principal diagonal, these are the covariances between various pairs of the variables. and this is for the other category, this is for sex, and the final one is for the consumption. I can also see state summary of these results. So it gives us the estimation of sample regression for all the variables that I have included in this model. So these are the mean values. The mean value of the systolic blood pressure is 130.8876. Its standard deviation is 23.34. Minimum blood pressure is this, and this is the maximum. This is the mean of the age. This is the standard deviation of the age. So minimum and maximum. This is for age. Sorry, for weight. The average value for the weight, the standard deviation, the minimum weight, and the maximum weight. And these are the minimum standard. These are the mean values, standard deviation values, minimum and maximum values for the various categories of. Since this is categorical, so although it's either 0 or 1, so that is why its minimum value is 0 and maximum is 1. And also this is indicator variable. So this is for female. So it means that 52% of the sample individuals constitute female population in this. This is its standard deviation, and the one shows the number of females. Finally, I can also check normality of the data, and for normality I can say JB and EI, and this is the normality, Jarka-Berra normality test. The null hypothesis is that the error term or the residual follow normality, and its computed chi-square value is 3576, and its p-value is 0. So it means this is highly significant. So we reject the assumption of normality for this model. So these are the various commands that we can use how to test variables, how to test various assumptions of the multiple linear regression model. We could have also used another assumption to test for this model, and that was the model of autocorrelation. But since this is cross-section data, and usually the cross-section data do not suffer from autocorrelation or serial correlation, so I didn't do that intentionally, but we can do that in my other videos. I think this is model number video number 109, in which I have used some technique how to test for autocorrelation. So you can check that. Thanks for watching this video, and if you have any question regarding this, you may ask me in the below comments, and I would like to come up with some answer. Thanks very much for watching this video. If you haven't yet subscribed, subscribe to the model, and do not forget to click on bell icon. You will get regular information about my videos that will be uploaded for you. Kindly share this channel and various videos with your friends, with your colleagues, and with your students, and also share this in various WhatsApp groups so that the data and these videos could reach to the maximum possible number of people. Thank you for your cooperation.